Hello dear students, so now we would move ahead in this chapter number 1 of class 10th mathematics, that is real numbers. So here I have some new questions for you, and the question number 1 is prove that the product of two consecutive positive integers is divisible by 2. If you are taking two positive integers, you are multiplying them, so their product would always be divisible by 2. That you have to prove. Okay, let's say we have two positive integers here. Okay, let n and n plus 1. Consecutive means one after another. So if one is n, another would be n plus 1. Okay, so let's say n and n plus 1 are the two consecutive positive integers. Consecutive positive integers. So these are the two integers. Okay, now if I multiply, what would be the product of these two would be, because you have to prove the product of these two integers would always be divisible by 2. That you have to prove. So let's find out the product of these two integers. So first one is n, second one is n plus 1. So if you are multiplying this as in n inside, so n into n would be n square plus n into 1 would be n. So you have the product n square plus n. Now you have to prove whether this product is divisible by 2 or not. Now one thing we are knowing, we have already discussed in the previous lecture, that any positive integer is of the form 2q or 2q plus 1. That we have proved also in the previous lecture. You go through the previous lecture, there you would find this one question. Prove that any positive integer is of the form 2q or 2q plus 1. Okay, now we are knowing any positive integer is of the form, right here, as we know any positive integer is of the form 2q or 2q plus 1. Any positive integer you are taking, whether it would be in the form of 2q or it would be in the form of 2q plus 1. Okay, now if it is in the form of 2q, let's say n is 2q now. Let's say n is 2q. So what would be the product? Now if n is 2q, so product would be what? Product would be what? In place of n you put 2q, so it would be square of 2q plus 2q. In place of n, just put there the value 2q. So square of 2 square of 2 is 4, so it would be 4q square plus 2q. You can take 2 common here. So if you are taking 2 common, so what would left here? 2 to the 4. 2q would left here, and what would left here? Here only q would left here. Now you can see, if n is 2q, then the product is divisible by 2, because you are taking 2 common. If you are dividing it by 2, it would be divided by 2. Are you getting this? Yes. So any positive integer would always be divisible by 2. Yes or not? We have proved this. If n is 2q, then it would be divisible by 2. Now we have to check whether if n is 2q plus 1, whether it is again divisible by 2 or not. That is again we would prove now. Okay, so here in the first case we have proved yes, any positive integer, any consecutive positive integers, so their product would always be divisible by 2. If you are taking positive integer 2q and 2q plus 1, here value of n I have taken 2q, so first it would be 2q and second would be 2q plus 1. If you are multiplying these two, so product is this much, so product is also divisible by 2. Are you getting this? So hence every positive integer means consecutive positive integers, the product of two consecutive positive integers would be divisible by 2. Now one more value would put here. Now if n is now 2q plus 1, put here if n is 2q plus 1. If n is, because any positive integer is of the form 2q or 2q plus 1. Any positive integer, whatever the integer you are taking, would be of the form either 2q or 2q plus 1. So if it is 2q, yes, the product is divisible by 2. Now if it is 2q plus 1, whether it is divisible by 2 or not, that again we have to prove now. Okay, now let's see here. If n is 2q plus 1, let's find out the product. What would be the product then? Product would be, now look here, n square plus 1. So in place of n you have to put the value there 2q plus 1. So it would be 2q plus 1 whole square plus, in place of n again 2q plus 1. Are you getting this? Very good. Okay, now let's solve this. Whole square open, a plus b whole square would be a square plus b square plus 2ab. So a square is 2q square, square of 2q square is 4q square. A square plus b square, that is 1, square of 1 is 1, plus 2ab, 2 to the 4 4q into 1, 4q. Are you getting this? So this is how you would open the whole square. You are knowing this, okay? Similarly here 2q plus 1. Here no whole square is there, so it would be 2q plus 1. Just add this 4q square plus 4q plus 2q would be 6q. Similarly 1 plus 1 would be 2. So now if you see, I can take again 2 common here. So if I am taking 2 common, what would left here? 2q square would left here. Here 2 3 ja 6 means 3q would left here. Here 2 1 ja 2, only 1 would left here. If you are, just look now, again it is divisible by 2, because if you are dividing it by 2, 2 and 2 would cancel each other. Okay, so hence if n is 2q plus 1, then again the product is divisible by 2 here. Are you getting this? So hence we have proved that any two consecutive positive, hence we have proved that the product of two consecutive positive integers is always divisible by 2. In first case also, in second case also. So at the last you would write here, hence the product of any two consecutive integer is divisible by 2. That you have to write on your own. Okay, right here, hence the product of any two consecutive positive integers is always divisible by 2. We have proved this. Okay, just note it down. And now this is the next question here. The question is, show that the square of an odd positive integer is of the form 8q plus 1. Okay, so these sort of questions we are doing where we have to find out the square there. In the previous one there was not square in the previous video, if you have gone through that one video. Okay, so here we would discuss the square of the integers now. Okay, so here show that the square of an odd positive integer is of the form 8q plus 1, that you have to prove. Okay, so using Euclid's, right here, using Euclid Division Lemma that we are using, we are knowing any positive integer is of the form bq plus r. In place of q, because already given in the question q there, so let me write here m, something else. Okay, so any positive integer can be of the form bm plus r. So here m is the quotient here, no problem is there. I can write here m. Any other thing also you can write here. Okay, so you can write here n also, no problem at all. Okay, so a is equals to bm plus r, where r, the value of r is always greater than equal to 0 and less than b. Okay, now if in place of b I put the value there 8, because here has been given as 8 na? So yes, now put b equals to 8. So what would be the value of a? A would be 8m plus r. So where r would be equals to greater than equals to 0 and less than 8, because b is 8 here. Okay, so now what could be the value of r? R can be 0, r can be 1, because it is greater than 0 and could be 0 also. Okay, so r could be 0, 1, 2, 3, 4, 5, 6 and 7, not 8, because r is always less than 8 here. Okay, so it implies r is 0, 1, 2, 3, 4, 5, 6, 7. These could be the values of r. Okay, now show that the square of an odd positive integer you have to find out. Okay, odd integers. If now put the value of r here one by one. If r is 0, look here, if r is 0, so what would be the value of a? A would be equals to 8m plus 0, means a is equals to 8m. So 8m is what? 8m is even number, but you have to find out the square of an odd positive integers. So you would not take the value 0 here, because you have to find out the square of an odd positive integer here. Remember this. Are you getting this? Yeah. So if r is 0, so a would be equals to 8m plus 0, means a would be equals to 8m. So no need to take the value, because 8m is even number. Okay, so let me write one by one. If r equals to 0, then a would be 8m, which is even number. But we have to find out the square of odd number, not even number. Okay, now if r is equals to 1, so a would be 8m plus 1. 8m plus 1. So this is odd number, because 8m is even number, you are adding 1 there, so it would become odd number. Now you have to find out its square also, because you have to show that the square of an odd integer is of the form 8 cube plus 1. Now find out the square of this. So from here, a square would be 8m plus 1 whole square. You have to find out the square of the odd integer. Just whole square open. A square plus b square plus 2ab. A square is 64m square plus b square, that is 1, plus 2ab. 2ab. A to the 16, 1 the 16m. Okay. You can take in between these two, you can take 8 as common. Both are divisible by 8, so you can take 8 as common. So I can write it as, if I am taking 8 as common, so it would be 8 8 the 64. 8m square. And how much will left here? 2. 8 to the 16. So 2 would left here means 2m. So this one would remain outside, because I have taken 8 common from these two things. 1 would remain outside. Are you getting this? If I am taking 8 common, so this would be 8 8 the 64. 8 would left there, m square plus 8 to the 16, because 8 I have taken from 2 would left here. So m is already there. So it would be 8 outside, inside this, plus 1 would remain outside, because you cannot take 8 out of 1 common. Okay. Now this you can take, let's say this is some integer, let's say it is q. Let's say this complete is q. So I can write is that 8q plus 1, where q is equals to this. Are you getting it? This is already an integer. This is also an integer, na? So I can write is some other integer. Let's say it is q. So it implies this is 8q plus 1. Hence we have proved. Hence the square of an odd integer. This was an odd integer. So its square is of the form 8q plus 1. This we have to prove. We have proved it. Are you getting this? Getting this? Very good. Now other odd integer I am taking. Now if r is equals to 2, if I put r equals to 2, then I would get the value 8m plus 2, which would become even integer. But I have to find out the square of odd. I would not take the value 2 here. Now let's take the value 3. So a would be 8m plus 3. Now this is odd. Okay. If a equals to 3. So, sorry, r equals to 3. So a would be equals to, it implies a is how much? A is 8m plus 3, because a would be 8m plus 3 if r is equals to 3 there. So again it is odd. Yes or not? Yes or not? So if it is odd, then you find out its square, and its square should be of the form again 2q plus 1, because every odd integer if you are taking, its square will always be of the form 8q plus 1. Okay. Now find out its square. A square would be 8m plus 3 whole square. Okay. Now let's see. Open it. A square plus b square plus 2ab. Okay. So it would be a square plus square of b, means 3 square of 3 would be 9. A square plus b square plus 2ab. 2ab. 8 to the 16, 3 is 48m. Are you getting this? Getting this? Very good. This 9 can I write this 9 as 8 plus 1? Yes. I can write it as 64m square plus 48m. I am writing first. Then I am just dividing this 9 in the form of as the sum of 8 plus 1. 8 plus 1 is 9. Okay. Now among these all these three, I can take 8 as common, because all are divisible by 8. So I can take 8 as common. So I can write it as, if I am taking 8 out common, so it would be 8 8 the 64. So 8 would left here. And how much? 8 6 the 48. 6 would left here. And how much? 8 1 ja 8. 1 would left here. This 1 would remain outside. Now this is again an integer. Let's say it is again an integer, that is q. Let's say this is again an integer. Let's say it is q. Let's say it is q. So I can write this again as 8q plus 1. Let's say this is again an integer. Let's say it is q. So I can write this again as 8q plus 1. Hence again we have proved. Hence again the square of odd integer is again of the form 2q, 8q plus 1. In the previous also, square of odd integer was of the form 8q plus 1. In the again we have discussed square of odd integer is again of the form 8q plus 1. So in every case, now you would take the next one. If you are taking R3, now you take R is equals to 5. Then again you would get the same answer. Now if you are taking R is equals to 7, then again you are getting the same answer. No need to write this all, because with the help of these two we are getting the answer. Okay, no need to write to all the situations. Okay, so hence you can write there, hence right here, hence the square of an odd positive, hence the square of an odd positive integer, hence the square of an odd positive integer is of the form 8q plus 1, hence proved. This is how you would prove such questions. Are you getting this? Just note it down. And now this is the next question. The question is, prove that the square of any positive integer is of the form 3m or 3m plus 1, but not 3m plus 2. Same way, the way we have done the previous question, this question also you have to do like that. Okay, so prove that the square of any positive integer. Now here is no bar. It means you need not to take only the even integer. You will take even as well as the odd integer also. Okay, so whether it is even integer or it is an odd integer, so the square of both of these even and odd would be of the form 3m and 3m plus 1, but not of the form 3m plus 2. Remember this. So how would you solve this question? Okay, let's say you have an integer. Now right here, using Euclid's division lemma. Okay, we have an integer. If it is an integer a, it can be written of the form bq plus 1, bq plus r, sorry, bq plus r, where r is always greater than equals to 0 and less than b. Now what is the value of b here? Value of b is 3. So put value of b as 3. Put b equals to 3. You would get value of a as 3m plus r. Okay, where r would be greater than equals to 0 and less than b. B is what here? 3. So less than 3. So what could be the value of r? It implies r would be 0, 1 and 2, not 3, because it is less than 3 here. So one by one put the value and then find out the square, because you have to find out the square of all now, not only the even, not only the odd, even as well as the odd. Okay, so put the value of r is 0. Now right here, if r is equals to 0, it implies a would be equals to how much? If r is 0, so a would be 3m. Find out its square. No need to write even and odd, because you have to find out the square of everyone. Okay, so square would be how much? Square would be a square would be square of 3m, can be written as square of 3 is 9m square. A square is equals to 9m square. Now again I can write this as a square is equals to, this 9 can be written as 3 multiply 3. Yes or not? Yes. So I can write it as 3 multiply 3m square. Is there any problem? Should not be any problem. Like 9 can be written as 3 multiply 3. What is the problem? Now listen here. Let's say this 3m square is some other integer. Let's say it is q. Let's say it is q. So it can be written as 3q. 3q. Let's say this complete is q. So it implies a square is what? A square is equals to 3q. Are you getting this? A square is how much? A square is 3q here. So we have found the square of a positive integer is of the form 3q here. 3m is of the form 3m. So here one mistake we have done, that was q here, sorry, it was q, sorry. Right here in place of mq, in place of mq, in place of mq, and let's say this is some other integer, let's say it is m now. Is it clear? So hence the square of a positive integer is of the form 3m. Is it clear to you? Yes. Read it again because some mistake was there. So prove that the square of any positive integer is of the form 3m and 3m plus 1. Let's say we have a positive integer, that is a is equals to bq plus r. Then using Euclid's division lemma, put the value of b as 3. You will get a is equals to 3q plus r, where r would be greater than or equals to 0 but less than 3. So values of r are 0, 1 and 2. Okay, so if you put the value of r as 0, so you would get a is equals to 3q because r is 0. So if you are doing its square, so its square would become, square of 3q square would be 9m is 9q square. This is again would be 9q square. So 9, this 9 can be written as 3 multiply 3. Okay, so it would be 3 multiply 3q square. The 3q square is some other integer, let's say it is m. So I can write a square is equal to 3m. So a square is 3m. Okay, so it means the square of the positive integer is of the form 3m, that we have proved. Okay, now let's take the value of r as 1. Now if r is equals to 1, it implies a would be how much? 3q plus 1. 3q plus 1. So find out its square. So value, because we have to find out the square there. Okay, so a square would be equals to how much? 3q plus 1 whole square. Are you getting this? Just open it. A square plus b square plus 2ab. So it would be a square, means square of 3 is 9q square, plus b square, that is 1, square of 1 is 1, plus 2ab. 3 to the 6, 1 just 6q. Are you? 2ab how? 2 multiply a multiply b. This is 2ab. 3 to the 6, 1 just 6q. Okay? Yes. Now these two I would write together. So I can write it as a square would be equals to 9q square plus 6q. I would write together, and I can take 3 common here. I can take 3 common because these both are divisible by 3. So it would, what would left here? 3 3 is 9. So 3 would left here. So I can write here 3q square then. Why? Because I have taken 3 outside. Similarly here, if I divide it by 2, 3, I would get 2. So it would, what would left here? 2q. So if I am taking 3 outside, so inside 3q square plus 2q. This one would remain outside. This one would remain outside. Now let's say this inside one is some other integer. Let's say this integer is m. This is another integer. Let's say this is m. So if this is m, so I can again write it as 3m plus 1. 3m plus 1. Let's say this is complete is m, so I can write it as 3m plus 1. So hence the square of any positive integer is of the form 3m plus 1. Have proved. Getting this or not? Very good. Now let's take another value. Let's say a is equals to 2 now. Sorry, r is equals to 2 now. If r is 2, then what would be the value of a? It implies a would be how much? 3q plus 2. Are you getting this? 3q plus 2, because value of r is 2 now. So square it. Find out its square. A square would be 3q plus 2 whole square. Just open it. A square plus b square plus 2ab means it would be a square plus b square plus 2ab. 2, 3 to the 6, 6 to the 12. 12. Now between among these two, again I can take 3 common, but I can write this 4 as 3 plus 1. Remember this. It implies a square would be 9q square plus 12q plus this 4 can be written as 3 plus 1. Now among these 3 I can take 3 as common. So it implies a square would be equals to, if I am taking 3 common, so what would left here? 3 3 is 9, 3q square, 4 ja 4q, here 1, 3 1 ja 3, and this 1 would remain outside. Let's say this complete is an other integer, some other integer it is. Let's say it is m. So again it is of the form 3m plus 1. 3m plus 1. Now we have proved if you are taking any positive integer, it would always be of the form either of the form 3m or of the form 3m plus 1. Like in the first case, that was of the form 3m. Now in other cases, this is of the form 3m plus 1, 3m plus 1 here also. Okay. So the square of any positive integer is of the form 3m or 3m plus 1. But not 3m plus 2. Look here. Is it anywhere we are getting 3m plus 2? Nowhere we are getting 3m plus 2. So hence proved. Hence the square of any positive integer would be of the form 3m or 3m plus 1, but not 3m plus 2. We are not getting anywhere at 3m plus 2. So here write down at the last. At the last you have to write here. Right here. Hence means the complete answer you have to write here. It's a complete question like this. Hence the square of any positive integer is of the form 3m or 3m plus 1, but not 3m plus 2. That complete you have to write here. Then at the last, hence proved. Okay, so this is how you would solve the questions where you have to find out the square. Okay, now a little bit change in the question I am doing here. Okay, before this you note it down. Now I have some new question here. Look here. Prove that the square of any positive integer is of the form, here I am changing, is of the form 4q and 4q plus 1. But just leave it all. Okay. Prove that the square of any positive integer is of the form 4q or 4q plus 1. How would you solve this? Similar to this one. Let's say using Euclid Division Lemma, you have a is equals to bq. Do not write here q because q already in the question. Write here m. Okay. Let's say a is equal to bm plus r, where r is greater than equals to 0 and less than m. Put the value of b as how much now? 4. Put the value of b as 4. So value of a would be now how much? A would be 4m because q is m now here. Because a would be how much now? A would be equals to 4m plus r. So r would be greater than equals to 0 and less than 4. So values of r now 0, 1, 2, 3. These three value you would get. Okay. So now one by one put the value. If r is 0, then value of a would be 4m. Square it. You would get 16 m square. Like this 16 you would get. Not working. You would get 16 m square. 16 m square you are getting, na? Because if the value of r you are putting 0, so you will get a is equals to 4m plus 0. It would be 4m. Square of 4m would be 16 m square. 16 m square. This 16 m square can be written as 4 multiply 4. So 4 multiply 4 m square. So so let's say this is q. So it is 4q. So hence the square of any positive integer is of the form 4q. Now let's take another value of r. Let's say it is 1. So a would be 3m plus 1. Sorry, 4m plus 1. It is 4 there now. 4m plus 1. Square it. Just the way we have solved the previous question. Similarly, you have to solve this one question also. Are you getting this? Okay. Now similar to this, one more question I am having. One more question, write down. This question you have written. Yes, prove that the square of this 4q and 4q plus 1. Write another question now. Another question is, prove that the square of any positive integer is of the form, right here, 5q, 5q plus 1 or 5q plus 4. Similar to this one also. This is similar to this. Okay. Now here again you would take, let's say a is equals to bm plus, because q already given, right here m then. Okay. So a would be equals to bm plus r. So in place of b you put the value there 5 now. So a would be 5m plus r. So r value of r now 0, 1, 2, 3, 4. One by one put the value, then find out its square. You would get all in the form of 5q, 5q plus 1 and 5q plus 4. Are you getting? 0, 1, 2, 3, 4. All these 4 values you would put here. Okay. Okay, let me do this question here. You might be facing some problem here. Okay. Let me solve this here. Let me solve this question here. So question is, prove that the square of any positive integer is of the form 5q plus. All this I am doing here. Okay. Let's say using Euclid Division Lemma, we have A is equals to Bm plus R. Why M? Because Q already in the question, where R is greater than equals to 0 and less than B. So put the value of B as how much? 5. So you would get A equals to 5m plus R. Okay. So here R is greater than equals to 0 and less than 5. So values of R are what? Values of R are, it implies R would be equals to how much? R would be equals to 0, 1, 2, 3 and 4. Because R can be 0 but more than 0 but less than 5 here. Okay. So values of R would be 0, 1, 2, 3, 4. Okay. So now one by one put the value. Now if R is 0, so it implies A would be equals to how much? A is 5. A is 5m because R is 0. Now find out its square. So A square would be 5m square. Can be written as square of 5 is 25 m square. 25 can be written as 5 multiply 5. So I am writing it as 5 multiply 5 m square. Like this. So let's say this complete is Q. Let's say this complete is Q. So this would become of the form 5Q. Let's say this complete is in some other integer. Let's say it is Q. So it can be written as 5Q. Okay. So the square of a positive integer is of the form 5Q. Okay. Now let's take some other value. Let's say if R is 1, so A would be equals to how much? 5m plus 1. 5m plus 1. Find out its square again. So A square would be equals to square of 5m plus 1. Find out its square. A square plus B square plus 2ab. So A square is 25m square plus B square, that is 1, plus 2ab. 2 5 is 10. 10 1 is 10. 10m. Now between these two you can take 5 as common. If you are taking 5 as common between these two, because both are divisible by 5, so 5 you are taking common. So 5 5 is 25. So only 5m square would left. And this is 2 times. So 5 2 is 10. So 2m would left here. And this plus 1 would come out. Are you getting this? So it implies what? It implies what? Let's say this complete is some other integer. Let's say it is Q again. So you can write it as 5Q plus 1. 5Q plus 1. Are you getting this? Hence, the square of any positive integer is of the form 5Q. 5Q plus 1 and some more. 2 we have proved. Now some more you will prove. Okay. Now if R is 2 now. Let's say R is 2. So what would be the value of A? It implies A would be equals to 5m plus 2. Find out its square. It implies A square would be equals to how much? Square of, whole square of 5m plus 2 whole square. Okay, just find out its whole square. It would be A square plus B square plus 2ab, means A square plus B square, square of 2 is 4, plus 2ab. 2ab, 2 multiply A multiply B. 2 5 is 10, 2 is 20m. Getting this? Getting or not? Yes. Take 5 common, because between these two you can take 5 as common. Okay. So now you have the answer. It implies A square would be equals to, if you are taking between these two 5, so what would left? 5 5 is 25. So means 5m square would left. And this is divisible by 5 4 times. So you can write 4m. This is 4m. So 4 would remain outside. Let's say this complete is Q. So it implies what? It implies A square would be 5Q plus 4. Let's say this complete Q. So it is 5Q plus 4. Hence we have proved. Hence any positive integer is of the form 5Q or 5Q plus 1 or 5Q plus 4. This was already discussed in the question. Look at the question. Prove that the square of any positive integer is of the form 5Q, 5Q plus 1, 5Q plus 4. We have proved this. Okay. Now you can put some other values, or let's say the value of R is 3. Again you would get the answer like this, or like this, or like this. 5Q. If you are putting the value R as 3, so answer would be either of the form this, or of the form this, or of the form this. But no need to write all those values. It would become very lengthy then. Okay. So leave it here, because we have got all the answers here. Okay. So right here now, at the last you can write here. Hence, the square of any positive integer, right here, is of the form 5q comma 5q plus 1 or 5q plus 4. Hence proved. Okay, so this is how you would solve the question. Okay, okay, that's all for today. Would be discussing some new question in the next upcoming lectures. Till then, stay tuned, keep watching. Thank you, have a good day.